This video is to go over just kind of some basic surveying ideas, provide general instruction on some of the things that we need to do within our engineering environmental projects outside of completing an official survey. Obviously, that is something we leave to a licensed surveyor, and we get surveys anytime we do a design project. But there are sometimes we need either quick field measurements or adding things to what the survey did that we forgot to ask for, or things like that. So this is providing some of that basis and background to be able to complete those types of things. So there's three main survey needs that we generally have to perform. The first is shooting a road or ditch profile, and this is running a profile is basically getting relative elevations along the center line of either a road or a ditch. And so just shooting it at certain stations all along the center line. And we'll go into detail on each of these and how we actually do that here in a little bit. But just for the sake of now, that we're just going to provide a general definition. Shooting a cross section is taking relative elevations on each side of the center line at a designated station along the length of the center line. So the profile, basically, it runs all the way down center line, for, I guess, as far as you need it to. And a cross section is taking a spot along the center line, generally at the same stations you would use for your profile. And then now we're cutting basically laterally across and taking a look at that. And then the last one's fairly straightforward, just shooting flow lines or ordinary high water marks for creeks or culverts, things like that. Sometimes with a survey, depending on how they do it, whether they use LiDAR or different things, they can't get down in the weeds sometimes and shoot a pipe to get the actual flow line or things like that. But so sometimes that's necessary. And then also just establishing the ordinary high water marks, the jurisdictional boundary for a water in the United States that's regulated. So we have to pick that up so we can know the extent of the impacts to the creek channel for the environmental analysis. So we're just going to kind of go through some definitions just to provide you kind of a background on some of the terminology and some of the ideas presented here. So first I'm just talking about some of the views. We picked up on this a little bit in the previous slide. But here, and it may not be clear what this is if you're not familiar looking at it, but basically these pictures show a reinforced concrete box with lateral wing walls. So there's three different views of this. The first one, this top one here, is the plan view. And so a plan view is basically looking directly overhead of an object, so generally in two dimensions, and those dimensions represent the cardinal directions. So this box here, the red line actually represents the water flow line, so the wing walls, and then this is just the footing. But the water would flow across here, and then this is the actual box, so people would be driving in this direction. But again, that's just looking directly overhead. So the same box now, we kind of rotate it, and now we're looking at the profile. But this is from the side. So this is our roadway coming down this direction. And so if we turned that to the side, now we can see here's the wing walls, and then this is the opening for the box, so the water goes into this hole here. And this is just the railing up here, and then the footing down here. So we're looking at it basically from the side view, so as if we were standing right here but on the ground looking down into it. So the profile view, it's still two-dimensional, it's sliced basically, or just looking at it from the side. And so the last one, which we mentioned last time, is a section view. And so this is actually as if we were coming down on our profile or our center line of the road, and then say this red line, we just sliced. We were standing, say, right here, and then we look straight at this and we slice it in half, and that's what we get here. So the water flow is actually still kind of left to right, the same as it is in the plan view. So this is just what the inside, essentially, of this box looks like. The green here is just the roadway going over the top. And then the water would flow through here. But it's at a specific station, basically slicing it in half as you move along the center line. And it's basically perpendicular to the direction of the center line. So those are our three primary views that we use in engineering, and kind of represent some of the survey needs we'll need as well. So thinking about that, in the section view, a cross section, as we mentioned, is one of the main survey needs, and thinking about what a typical section for a roadway, just to orient you to that concept. Generally, for any roadway project, engineering project, we have what's called a typical section, which is, if you took a cross section, this is what on average we want it to look like. This is the way, the standard for which we're going to design this road. So if you look at this typical section here, again, so this is right here is the center line of the roadway, and so this is basically, we just cut straight down and are taking a look at it. So we have the two driving lanes here, 11 foot, and then we have an extra foot of pavement beyond the white line until the edge of pavement. And so you can see there's different types of pavement, and then there's a sub base here, and then all of this subgrade is just kind of, ground. So generally we have 2% slopes for the driving lanes, and then a 3-to-1 grade coming off of that. That goes down into our ditches, and normally there's a set distance that goes for about 6 feet, and a depth, and then we have our ditch, and then a 3-to-1 daylight after that. So just to kind of define these a little bit better. So thinking about grade and slope, so it's kind of the same idea, but you note here what I just mentioned. We represented it both in percent as well as a ratio, and so try not to get confused by that. Normally, bigger slopes are represented in ratios, so 3-to-1, 2-to-1. 3-to-1 is generally the maximum you can do without putting any type of barrier or guardrail on a roadway, and so that's kind of what we designed too. But here again, this is generally 3 feet horizontally out this way for every 1 foot vertically, whereas 2%, it's basically taking those numbers and dividing them out. So daylight, what we mentioned by that, so it can either be in a cut or fill scenario. So basically it's whatever this 3-to-1 slope, where does it meet existing ground? So if we're designing this and we're ripping all this up and building a new one. So if we're in a cut scenario where the existing ground is, say, way up here, we have to cut it down and then come back up. We want to maintain this specific slope, but we have to figure out the point at which basically it matches the existing ground. And the same thing for fill. So if the existing ground was down here, we have to fill all of this, but maintaining the slope until it meets the existing ground. So that's what we call daylight. And then cut and fill, again, it's just based on what the design calls for, based on whether there's existing ground that we either need to cut underneath it or fill on top of it to basically match our typical section. So getting more into surveying terms, and this is probably older, but these are the generic terms, but they stand for a lot of different things. So just the idea of a level, obviously we're more familiar with something being level, so represented by a bubble, like that. But in surveying, generally, a lot of times we refer to this entire instrument, So we have our tripod and then our ranging instrument, and this whole thing kind of gets thought of as a level. And the idea behind that is once you set this up, you generally adjust it until it is actually level. And so with the instrument, you have a singular like plane or line of sight over which you survey, and we'll get into that type of surveying, but that's kind of where that idea comes from. Another term is the rod, which you can see this guy holding here. So when you're looking through this surveying instrument, the level, what you're looking for is a mark on a rod, which somebody is generally out there holding. So this is an example kind of zoomed in, what it looks like. But again, it's just a very simple term. Some people use the term Philadelphia rod to represent a specific type of rod. But that's basically it, and we'll get into kind of how that's used in a minute. And this again, this would be to measure vertical distance, whereas a wheel, seen here, measures horizontal distance. You basically roll it along the ground, and it's calibrated based on the circumference of the wheel to be able to determine distance. Generally, as wheels go, the larger the actual size of the wheel is, the more accurate it is, because it's a larger circumference that it can use to validate those results. And lastly, another thing we can use for measuring distance is a tape, or sometimes people say chain, but generally a tape. Now, there's old versions that were actually steel, so not very tape-like, versus the new modern versions, which are more what you're used to as kind of a measuring tape, but just rolled up. So those are pretty much the typical equipment we use. It doesn't get a lot more complicated than that. There's dozens of types of levels out there, and we're not going to get into all those different types because basically we just have a single type we use for the company, but they all kind of operate generally in the same idea. So speaking of a rod, it seems fairly intuitive, or it should be intuitive how to read a rod, but it can confuse a lot of people sometimes. So basically a rod is just marked all the way up, just like a ruler. But the one difference, and you'll note here, both here and here, is each one of these bars, they're not individual lines the way they would be on a ruler. So this line does not just represent 4. Each side of the line represents a unit. So rods are broken up into decimal feet and not feet and inches. So each one of these bars, both the black bar and then the white gap, represent 1/10 of a foot. So I know this is a little grainy because I stole it from online and then blew it up, but basically if we look at the top of this bar, so it's pointing in at 7 feet exactly. So if we traverse basically the distance in this white area to the bottom of this black bar, we're at 7.01 feet. So so this bar is actually in hundreds. I guess that's true that it is in hundreds. Sorry, I need to back up a little bit. So each of these gaps is 100th and not 1/10. And then you'll see the actual 10th mark, basically where you're at in here. So each one of those, depending on the rod, I guess, it could be either way. Some are in tenths and some are in hundredths. But we look here, actually, I'm sorry, that was right. These are in hundreds, because if you look here, the red number is actually what foot you're in, and each of these black numbers are the tenths. And so within within there, you're in the hundredths. So if you were at the top of this bar, you would be at 9.40 feet. Okay, and so this would be 9.41, 2, 3, 4, 5. And so one thing you'll note, the way they, to make it a little bit easier, the way they angle these in is when it angles out to the top, like that, that means you're on a tenth. And so when you're coming up to it, the one that's set in is a ninth. Now they reverse that when you're halfway at a tenth. So the 5, the 0.05, sticks out and is angled in, but it's not sticking out as far as this one up here. So obviously this shows a crosshair, and so in the older instruments you would look through kind of a telescope, and it would have a crosshair in there, and then wherever the crosshair hit, that's where you would read the rod. We use a laser level, and so instead of looking at a line of sight, basically a laser emits a signal. So you level the instrument and then it shoots out a laser, and where that hits is basically your line of sight. So we have this kind of laser targeter, and so you can see it kind of points. You clip it onto the rod and you can slide it up and down, and so it'll generally have an arrow that says go up, go down, and then once you've hit the mark, it'll show a solid line here, and it'll beep and let you know where you're at, and that's when you can tighten it up, the little screw handle on the rod, and then you can read the rod straight off of that. So here, if we read where it's marked, we would be at 9 feet and 9.70 feet, because we're right on that line there. So sorry that was a little confusing, but yes, so again, the red numbers indicate the feet. The black numbers here will indicate tenths, and then each one of the dashes is a hundredth. So a few more definitions, specifically for when we're actually doing our surveying. So a benchmark is generally an established point of known elevation. This is kind of how we start all of our surveys. We don't know where we are in the world unless we reference something that we do know. And so we use a benchmark. Generally, this is a point of known elevation. Somebody has gone out there, figured this out before us, and we or it can be an assumed point of known elevation. We can assume an elevation and go from there. But that's what we base basically all the other elevations off of. So I didn't put it in here, but we'll talk about it in a little bit, but I guess it's on the next one. So a turning point is a temporary point of known elevation used to reset our instrument position. And again, we'll get in more detail of that. So I mentioned these earlier. A flow line is just the elevation of the water flow for a creek or a culvert. And again, I'll reference that later, but basically this is kind of the lowest point at which water flows to get into a creek or a culvert. In the ordinary high water mark, that's something we'll discuss it in a bit more detail, but basically this is a jurisdictional boundary for a waters of the United States. This is the regulatory waters based on the Clean Water Act, and it's based on the average flow characteristics of a water, and you just have to be able to identify that on the field based on characteristics of the creek. Okay, so the last slide in this lesson, just kind of the background, some more definitions. So differential leveling, this is a survey practice basically used to establish the difference in elevation between 2+ points. Generally, you start out with a single benchmark of known elevation, and you keep shooting to get to the next point that you're looking for. And this is one thing we'll go into a lot of detail and explain the whole process in the next video. So within differential leveling, there's a couple of concepts you need to understand. For one, we discussed benchmarks, but a foresight, and a foresight or foreshot is a shot on a point of unknown elevation. I guess I should have put these the other way, but basically, foresight is the instrument height. To calculate the elevation is the instrument height minus the foresight. So the foresight, that means the reading on the rod. So when we look at our target, what's the reading of how many feet above ground are we? And then a back sight is a shot on a point of known elevation. And this is how we actually establish the instrument height here. And then the instrument height is the elevation of the instrument line of sight above the benchmark. So the elevation of the benchmark plus the back sight, so the rod reading on the back sight, equals the instrument height. So all of this will make a little bit more sense in the next video when we discuss the process of actually doing a differential leveling survey and using all these concepts to complete that survey and determine the elevation of unknown features. So that's it for this video. Thanks.